In this lesson, we're going to learn about translations, or what are also known as glides. These are the transformations that control the movement of an object, either left, right, up, or down, or any combination of those moves. There are two styles of symbolizing translations. The first one is coordinate notation. In coordinate notation, you'll see a symbolism similar to this first example here, where you have x, y, and then you got an arrow. The arrow is read as map to x plus 4, y minus 2. Well, the x movement, if it is plus, it moves right. If it's minus, it moves left, just like you're moving along the x-axis. So x plus 4 moves every single point in the original object right 4 spots. And then the y movement is the moves along the y-axis, which is up and down. So y minus 2 would symbolize moving down 2. So you would take every single point in that problem and from the original object, the pre-image, and move every point right 4 and down 2. In our second example of coordinate notation, this one here, the x has no plus or minus, which means it stays put. This is not, there's no movement left or right on this one because there's no number being added or subtracted from the x. So the only move on this would be the y is a plus 3, which means it moves every single point up 3 locations, or up 3 spots. The second type of notation is called vector notation. In vector notation, you'll see two parenthesis-looking shapes, which are pretty much a greater than, less than sign as your open and closed parentheses. The first number in vector notation is the change in the x. The second number is the change in the y. So simply vector notation of 3, negative 1 tells us that we would move right 3, and down 1. So you take every point in the pre-image, move right 3, down 1. So our second form of, or our second example of vector notation here tells us that we would move left 4. First number is your left or right movement. Negative is left, positive is right, and then up and down is our second number, and that is up or down 0. So we would say that our second notation here tells us to move every single point left 4 units. So here in this example, what we have is we want to find the location of S prime under the given translation of square SQUR that has vertices at 0, 2, 3, 1, 2, negative 2, and negative 1, 1. And then they give you the translation notation right here. This translation notation tells us that we're going to take every point, we're going to move it right 3 positions, and up 1 position. So I'm going to do that for this whole thing, and then we'll answer the question here. So if I take every point, move them right 3, up 1. So if I take S, go right 3, up 1, S prime would end up right there. Q, go left 3, up 1. That's where Q prime would go. U prime would end up right there. And R prime would end up there. So I can go here and draw my image, which would look like that. Now, to answer the question, find S prime. S prime is at, let's see, this is 1, 2, 3. Looks like 3, 3 to me. Make sure when you enter or put those answers in that you got your parentheses, you got your comma, no spaces, no extra stuff. Do not put the S prime in there. Just parenthesis 3 comma 3 parenthesis, and that would be your answer. So let's say they don't give us a graph. The graphing one was a pretty basic example that we just did. But let's say they ask you to find r prime for the given situation. They tell you that r is at negative 3, 8, and it's translated using the rule xy is mapped to x plus 1, y minus 3. Now we talked about how the x plus 1 means we are moving right one spot, and the y minus 3 means we are moving down 3 spots. That doesn't really help us a whole lot unless we go out and graph this. So another way of looking at this is, what are we actually doing to our x value? We are actually just adding 1 to it. So if we add 1 to negative 3, that puts us at negative 2. And then for the y part, we are subtracting 3 from it. So if I subtract 3 from the 8, that ends up at 5. Funny enough, if we were to graph this point out and follow this rule, we would end up at negative 2, 5 for our value for r prime. So keep that in mind as we're going through these types of problems, that if they don't give you a graph, it's really no big deal on this. These types of problems. Add 1 to the x, minus 3 from the y. Just follow the rule going from your pre-image to your image. The one thing you got to be careful of is what happens if they flip stuff around. They say find t for the given situation. Understand now they're asking you to find the pre-image, giving you the image. They're asking you to work backwards. In our previous example, they're asking for the image given the pre-image. That's working normal direction, working from the original to the final. This one we're trying to find the original from the final. So this one you got to be a little careful of. Same concept though, but we're going to go opposite. Our rule tells us, going from the pre-image to the image, that we would go left 3 and up 2. That means if we go in reverse, to go back to the beginning from the final image, we would have to go right 3 and down 2. That's the rule we're going to apply to this problem. We would go right 3, which is a plus 3, and a down 2, which is a minus 2. So that puts us at 9, 8 as the original coordinates of t in that problem. So if I took the original here, applied the rule, I would end up at the image. There are two interesting facts about glides or translations. Translations are the only transformation in which all the points move the exact same distance. Every single point moves the same distance in translations. Whether you're just horizontal, just vertical, or diagonal, and to move diagonal is just a combination of horizontal and vertical moves. The second one is that if you reflect an image over a line and then take that image and reflect it again over another line that's parallel to the first line, the end result is a translation. So here's what we're talking about reflecting a object over parallel lines and having the end result be a translation. So what I'm going to do here is I have GeoGebra opened up. I'm going to take a line, draw a line here. I'm going to draw a polygon over on one side. We'll make it kind of a unique polygon, make it easy to tell the reflection and the translation. So what I'm going to do is I'm going to take that polygon right there. There we go. We're going to select that object. And we are going to reflect it. Just got to find my reflection tool right here. Reflect it about that line. So here's our first reflection. Now, as I move this line around, you can see the reflection. Reflections can overlap. They can go left side, right side. I could rotate it around so it goes up and down if I like, but there's a reflection. So now what I need to do here is I'm going to create a parallel line to line AB. I must have passed up that tool. There's parallel line. Parallel line from there over here. So there's our parallel line. Now what I'm going to do is I'm going to grab our image, our first image, and I'm going to reflect that over that second line. Now, from this original image to this second image is a translation. You'll see that the orientation and all the parts of it are exactly the same as the original, just slid over. So now if I make our lines basically perpendicular or vertical is probably a better term for that. If I made them vertical, this image, or the pre-image, and the second image, all it is a movement to the right a certain number of places. Now it doesn't matter if the lines are vertical, horizontal, or diagonal. The relationship between the original pre-image and the final image, when you're talking about reflecting over parallel lines, is always the end result of a translation. This would be a glide where you move right and then down. Now I could even make it look a little more complex like this, but still the picture is pretty easy to follow because the ABCD with no primes, that's the original. This is the first image because it has the single prime marks, and this is our second image here. If I do this perfect, I could probably get those to end up going right where that second image is exactly right on top of the image, even if I wanted to. So we could move it all over the place. No matter where I put that, or move the lines, or separate my two lines together, the end result is from first object to second image, or pre-image to second image, the end result is a translation.